Topic 6-1, Graphing Quadratic Functions. This can be referenced in our whole textbook, Chapter 9, Sections 1, 2, and 3. On page, each of those sections starts at 590, 599, and 606. Okay, this whole chapter is on graphing functions. So this topic unit, we're going to focus on those things that you will be tested over. And one of the main things I need my students to remember is the quadratic function is always denoted, and they should get in the habit of being able to see that anytime you have a y equals something, if it has a square to the x to a power of 2, then we know that it's a quadratic. All right? If the graph of the parabola goes up and its vertex is at the lowest point, then that will have a positive x squared. If you see a parabola, it's called a parabola, that goes this direction with its vertex at the top, that is like an example of an equation with a negative x squared. So whatever value is in front of your x, whatever coefficient, if it's positive, the parabola will go this direction, and if it's negative, it's going to go this direction. Okay, the axis of symmetry. If I can cut any piece into a half, it would be like, I probably should have a piece of graph paper to have done this, but if I were to draw just any picture, like a heart, and say the axis of symmetry is the point at which it could be cut in half, where we have equal parts on one side and equal parts on the other side. So from any point along this axis, if I counted the number of points out to any symmetrical side, those numbers would be exact. So a lot of times when we're getting points on these parabolas, the axis of symmetry is important. So your axis of symmetry, I'll keep highlighting these, the axis would be this line that cuts that directly into equal halves on either side of the parabola. Okay, there is a formula for finding the axis of symmetry. So in this equation, the A is understood to be here, the B is the -4, whatever's in front of the second term, and then C is always the number that's the last term. So if there's just an x squared, it's understood to be a 1. So that's why A is 1, B is -4, and the C is 5. Knowing this A x squared plus, and usually they use capital letters, bx plus c. So that we're looking at just the numbers A, B, and C. If you use this formula, you can also find the axis of symmetry. So the axis of symmetry for this particular equation would be a vertical line where x is equal to 2. If you were to find the vertex, you would substitute that 2 in for x because the axis of symmetry goes through the vertex. So notice how they're substituting. Everywhere there was an x is now a 2. They put this 2 into 1x squared minus 4x plus 5 is equal to, once they did that operation, their answer was 1. So a vertex point is always your x, y. I try to let my kids know that axis of symmetry is just the x of your vertex point. But we're going to do some other examples and get a little bit better understanding of this graphing. Okay, if you were going to find a point that reflects across that, just like when I was showing the heart, if this is the vertex point, then if you choose any value of x that is 1 or 2 units away from the vertex, So if I say 2 units this way and 2 units this way, and substitute 1 in. If x is 0, notice how they're using the same equation from this problem. Plugging in a 0 would give us just a 5. So one of the points would be at 0, 5. So we go 0, 5. That's 2 away from the axis of symmetry. So then at the axis I would go 2 points this direction, and that's going to also be a point because they're reflected to get the other point. Okay, so here's another formula. If you have negative x squared, remember I told you negatives are going to be upside down, and you plug in your a and your b. Actually, for the formula for axis of symmetry, you don't really need the c. But plugging in a negative, because it's a negative of the b, so it's opposite. You can say that as opposite of what the b is. So if b is 2, its opposite would be negative 2 times, divided by 2 times the negative, whatever the a is, which is negative 1. So this happens to be the vertex is at, x is at 1. So our x is here. Substituting 1 into the equation gets you y to be 0, so that is my vertex. Finding points that reflect across, we can choose 3. Once you substitute in 3, and get your answer, you're substituting it into the equation, your original equation that was negative x squared plus 2x minus 1. You're just plugging in a number for x, and they got that to be, the y to be a negative 4. So you plot that point, 3, negative 4. So you walk over 3 and go down negative 4. Then it's just a reflection. That went 2 points this direction from right here. So you can kind of think, let's see if I can do that with that pink. You've gone 2 points to reflect that way, so of your axis of symmetry, you're going to go 2 points that way. I usually try to tell kids to get 4 points so that you have 2 points here and 2 points here and the vertex point to draw a pretty parabola. But it can be done with just the vertex and 2 other points that have been reflected across. So we'll do a few more sketching parabolas, but I'm also going to show you something, how to actually find these points in a calculator too, in some topics that we'll be doing next. But that'll be all for topic 6.1.